Find the area and perimeter of a composite figure. What you want to do is break the figure into known shapes. So we want to find the area and perimeter of each shape, and then we're going to add all those values together. For example, this guy right here, I've got this kind of trapezoidal shape, and I've broken it up into 3 different shapes. I've got a triangle, a rectangle, and another triangle, and I want to find the area of this shape. So I'm going to take the area of the rectangle, and I'm going to add the areas of individual triangles. And we know the area of a rectangle is length times width. We're going to take the length of 24, we'll multiply by the width. I get 384 centimeters squared. Okay, we'll look at this first triangle. You'll remember that area of a triangle is half of a base times height. We've got a base of 12 centimeters. This height is going to be the same measurement as this height. We've got our base and our height. We're going to multiply by half, and we'll get 96 centimeters squared. That's one of our triangles. The last one is going to be the same calculation, just with our 4 centimeter base, same 16 centimeter height. That should give us 32 centimeters squared. So we've got 3 areas. We're going to add those 3 areas together, which will give us 512 centimeters squared. Follow up to part A here, we're looking at the same shape, but this time we're looking at the perimeter of the shape. We know that this is 24, we know that this side's 24. We've got a 4 centimeter side here and a 12 centimeter side here. So really the only thing that we're missing in this triangle would be this side and this side. So what we have to do is somehow get the lengths of these sides. But conveniently enough, we do have a tool for that, and we're going to use the Pythagorean Theorem. Remember, Pythagorean Theorem says if I have 2 sides of a right angle triangle, I can find the third. Remember, Pythagorean Theorem looks like this. I've got side A and I've got side B, and I'm going to substitute those in. We end up with 20 centimeters as our measurement of our hypotenuse. So I'm going to do the same calculation for this triangle to find the hypotenuse of this triangle, and I end up with about 16.49 centimeters. So now that we have the measurements of all the sides of our shape, we can add them all together, and that'll give us our total perimeter. So taking this concept a little further, we're going to look at this kind of bizarre shape here. If we were being asked to find the area of this shape, you can see that this is pretty much a rectangle with half of a circle cut out of it. So to find the area of this shape, we're going to treat this as a rectangle, find the area of that rectangle, and then subtract out the area of half of a circle. The first thing we're going to do, we're going to find the area of this whole region, and then we're going to subtract out the area of this shaded circular region. We know that the area of a rectangle is length times width. So if I plug in those 2 measurements, I get 10.92 meters squared. But I want to remove this semicircle portion. The area of a circle is pi r squared. So if we want half of the area of a circle, it makes sense to multiply the area of a circle by a half. In this case, we know that the diameter of this circle is 2.1 meters. So if I take half of the diameter, that'll give me my radius, which is 1.05. You end up with 1.73 meters squared. So remember, that's going to be the area of this shaded region here. We've got the area of our whole rectangle. All we have to do is subtract the area of a rectangle minus the area of half a circle will give us our total area, which ends up being 9.19 meters squared. The second part here is finding the perimeter of the shape. We want to look at this thing as a circle. We know that the circumference of a circle is pi times d, where d is the diameter. We're looking at half of a circle, so I'm going to just call this new quantity L. Really all I'm doing is just dividing pi d by 2. So that's the circumference of a circle divided by 2. So that's going to be this distance around my semicircle. And we end up with 3.3 meters. I can just add one of these sides, another one of those sides. 2.1 meters was the width of my rectangle, and our newly found half circumference of our circle is 3.3 meters. So if I add all those 3 together, I end up with 15.8 meters.